Hello everyone, welcome back to my channel, and with today our problem. This is the daily problem in lead code, and we have the maximum Manhattan distance after k changes. So we are in here, we have the string s, and in the string s we have 4 characters. It consists of 4 characters n, s, e, and w, and each character denotes for movement in one direction by 1 unit. So here, like, our task is to calculate the maximum Manhattan distance from the origin that can be achieved anytime while performing movements in order. So it means that in here, like, we need to consider the string step by step, and we need to return the maximum Manhattan distance if we find it. So here, like, so okay, so this is the closed form solution of the Manhattan distance, and so from this formula we can rewrite it as like using the frequency of n, s, e, and w like this. So let's say that we have the frequency of n, frequency of s, plus the frequency of w, and the frequency of e, right? So this is, we can convert this formula into the Manhattan distance using the frequency like this. So here's the way we can calculate, or this is the maybe favorable condition for us to calculate the Manhattan distance in each step. I mean that this is the iterative step, right? We have so many steps in here, we have 4. Okay, so we need to come up with something else, because like we need to apply some changes. So here, like, we have k changes, and let's say that we apply k changes into this string, for example. So in here, like, we have the frequency of n, let's say the n, w, s, and e. So the frequency is what? 1, 1, 1, and 1, right? And we have k changes. So in here, now let's assume that I am applying the k changes after 4 steps. I mean, we are here in the 4th step, right? We have done. Okay, so here, like, the frequency is 1 minus 1 plus 1 minus 1. For example, yeah, this is no changes. Okay, so no change, and then 0. Okay, what if I change one of the characters in here? Yeah, so let's say I will transform the s into e and vice versa. So in here I will replace one s by one e. So this one will be NWE. So this one is 1, 1, and this the s, right? The s will be 0, and the e will be 2. So it will be 0 by minus 2, right? This is equal to 2. Okay, so yeah, if we apply the change in the after 4 steps, and then we have the result of 2, so we can see that how can we come up with this formula, or how can we get this number in general. We need a formula. So in here, whenever we substitute one of the characters by another character, so it means that we reduce 1 here, and we will replace by 0, but we add up 1 in here, right? So it means that in here, like, this is the k. Okay, so number of changes. So in here it means that somehow, like, in here we need to plus 2k, 2 by k. So this is our closed form solution to calculate in each step for the Manhattan distance. Okay, so in here, so you can see that if the k, like in this case, for example, if the k equal to if we okay, so in here, like, we can see that in the second example, and if the k equal to 3, so 2 by k equal to 6 already, right? So it, no matter what we have in the string, no matter what is the step, for example, like, I just have the n in here, n, s, and we have the w. After just 3 steps, if we apply the same logic in here, so it means that somehow, like, in here the frequency of this one is like 1 minus 1, right? And then, so in here we have 1 minus 0 plus 6. Okay, so this one is greater than the length. of the s. So this is the incorrect value. So in each step we need to consider, because of this, so in each step we need to consider what? We need to consider length of the string, length of the string. I mean length of s, I mean length of the substring in here, like we have n, s, and w, and the length the substring, right? And this value, I need this formula f, I will, and we need to get the minimize of this, right? Which one is smaller? We will get this one, because like if in here, of course, like I have three changes, right? I have three changes. It means what? It means that maximize that we have the length of 3. In that case, we replace all the string in here, I mean all the characters in here, with only one string, for example, with one type of character, for example, like n, right? So maximum we have Manhattan distance of 3, right? So that is the way, like, so length of s in of the substring in here, it means that length of this one, length of this one, or length of this one, okay? Or like the f in here, if the length of s is greater, and then at max we only can achieve this value at max, right? So it means that we only get the mean. Okay, so when we iterate over and over the string, we also need the iterative, right? Okay, so I think that this is quite pretty yeah, straightforward to for us to make the code. But before that, we need some kind of the observation to accelerate the programming. So let's see, our program needs something to be maybe faster, so we can have some observation. I mean, this is the second observation. So okay, so let's say that I have n, s, and w, and let's say that if the in here I have the count, I mean the number of the characters is 3, right? And this one is smaller or equal than k. So I mean that this one, I mean that this length of substring, this is always equal to this number, because in that case we can substitute all of the other characters except n to n, for example. We can always n and n, right? So in here, like, we can avoid of the min operation, len operation, and the f operation in here. So we may come up with the strategies to just replace this one with the length of the substring. Okay, so in this case we can accelerate our program a lot. So that's why I think that's all the things. Just we have this one is the second one, and we have this one is the first one, and we will utilize this one as well. So let's mark it 3, and then we will combine all the things together for program. Okay, so I hope you can see my screen. Okay, so to calculate the frequency first, and then we just define the hash map. So here I will predefine it to fasten the procedure. So here like S, we have E as well, and the last one we will have the W denote for the west, and then we will have the max value. This one we will store the max value through iterative steps, and we have the count. This one we have me to, like, yeah, estimate the length of the substring. Okay, so here, like, we have substring, iterate about substring. We can get the hash map of C. Okay, and then count. Okay, so what if, okay, so here, like, let's get back to this. Let's get back to this, so we can see that in here, if this one is the 3, right, and it means that we can substitute the let's say that this is the length is L, and then we can substitute L minus 1 characters, right? L minus 1 characters. We don't need to replace all 3 characters by by n we only need to replace 2 characters, so that's why that is the, let's say L equal E3, and then we just need to replace 2. Okay, so here, so we can see that we can consider if the count minus 1 equal k, so it means that we can replace all of the characters with k, right? Otherwise we can have the temporal value, and then this one will be the mean of the count has map. So for now we will calculate the Manhattan distance. So here, like, we will get the absolute value of the hazmat n minus hazmat of s, and this one we should absolute of hazmat of e, and hazmat of w, and we need to plus 2 by k, right? Okay, so for now we can get the max val equal to max of max and max val. Okay, so here I will return the max val. Okay, let's run. Okay, looks good. Yeah, okay, so let's submit. Okay, so I can defeat 100% of other programmers. So here, let's submit it again. The memory usage is still a lot. Okay, again, let's see the statistics. Okay, looks good. Yeah, so I think that's it for today, and thank you for watching my video. See you next time. Yeah, hope that if you find that this video is useful for you, and please give me a like, and if you can just give me a comment, what do you think about my video, for me to improve my channel in the future. Thank you so much for watching my video. Okay, see you next time.